Hey everybody, and welcome to one of the first online math lessons. We're going to be talking about 9.4, solving quadratics by factoring. So one of the first things we're going to have to do is remember how to factor. So here's our first little problem we're going to start with. Remember that the 10 is our target number. We need to ask ourselves the question, what multiplies to 10 but adds to the coefficient of the linear term 7. So we need to think about two numbers that multiply to equal 10 but add to equal 7, 5 and 2. So then, because our coefficient of the quadratic term is 1, all we need to do then is create our two different factors. What do I multiply by itself to get x squared? That's x times another x. And these two values are both positive 5 and positive 2. So how does x squared plus 7x plus 10 factor? It factors to x plus 5 times x plus 2. Now, if you remember, we can always check to see if we are correct. So we're going to check our work by taking x times x, which is x squared, x times 2, which is 2x, 5 times x, which is 5x, and 5 times 2, which is 10. We have our x squared, we have our 10, and the 2x and the 5x, both of those linear terms add together to equal our 7x. And it checks out, and we factored it correctly. So how does this connect with what we've been talking about with solving quadratics? If you remember back in 9.3, we learned that a solution to a quadratic function is or are the x values that make y equal 0. So in remembering that a solution to a quadratic function is or are the x values that make y equal 0, let's look back at our factored form up here. We have two factors. We have the factor x plus 5, and we have the factor x plus 2. What we now need to ask ourselves is what makes these two individual factors equal 0 all individually? Well, you can solve that simple equation by subtracting 5 to both sides and getting that x equals -5. Subtract 2 to both sides and getting that x equals -2. Now, why does this help us be able to find a solution? Well, think about this very simple question here. What is 0 times any number? When I take 0 and I multiply it by any other number, let's call it a. 0 times the number a is 0. 0 times 5 is 0. 0 times -3 is 0. So if we look back at our factored form up here, and if we wanted to replace x with -5, if we plug it into this original one up here, you would get that -5 plus 5 outside of -5 plus 2. -5 plus 5 is 0. -5 plus 2 is -3. So we now have the statement that 0 times -3, but what is 0 times -3? Well, that's 0. So we just found that one of the values that makes y equal 0 is -5. But we could do the exact same thing with our other factor on this side of the x plus 2. What makes x plus 2 equal 0? Well, it's -2. So I could plug back into the original function, x equaling -2. And if I plug in -2, over here, we get positive 3, but over here we get 0. And again, 3 times 0 is 0. So it makes y equal 0. So if we remember, the solution to a quadratic function is or are the x values that make y equal 0. We are trying to find values of x that make y equal 0. When you can factor it, you can set each individual factor equal to 0 separately. And when you set them equal to 0 separately, you find the x values that make y equal 0. The whole idea that 0 times any other number is 0, this is known as the zero product property. Literally, product is another word for multiply. Property means what something does mathematically. So 0 multiplying mathematically makes something 0. So then we could answer the question, what is or are the solutions to the equation? We've replaced y with 0. 0 equals x squared plus 7x plus 10. We factor it. What multiplies to 10 but adds to 7? Positive 5 and positive 2. I then set both of these factors equal to 0 separately. Then I solve both of these separately. And I get one answer. One solution is negative 5. And another solution is negative 2. So let's try it again. Now remember, another way of saying find the solutions is to ask to find the x-axis intersections. There is no difference between y equaling 0 and the x-axis. When you look at an xy plane, this horizontal line right here is where y equals 0. So when you're looking for solutions, which is y equals 0, or you could say find the x-axis intersection. So I'm going to go down here. I'm going to do it again. My target number is 15. What multiplies to 15 but adds to 8? The answer would be 5 times 3. 5 times 3 is 15, but 5 plus 3 is 8. So to find the x-axis intersections, I can replace y with 0, because where y equals 0 is the x-axis. And then, again, I have a leading coefficient on that quadratic of 1, so I don't have to factor by grouping. I can just go straight to x plus 5 and x plus 3. So I have factored it. Now, what do I do after I factored it? I take my two factors and I set them equal to 0 separately. Because if one of them equals 0, when I multiply that 0 to the other number, regardless of what it is, I get 0 because of the zero product property. So x plus 5 equals 0. I need to subtract over 5, and I get one solution that x equals negative 5. I subtract over 3, getting my other solution that x equals negative 3. So again, I need to factor it. I replace y with 0. My target number this time is negative 14. What multiplies to negative 14 but adds to negative 5? The answer is negative 7 and positive 2. Negative 7 plus 2 is negative 5. Negative 7 times 2 is negative 14. I don't have to factor by grouping, so x minus 7 times x plus 2. Set both factors equal to 0 separately. Add 7 over, subtract 2 over, x equals 7, x equals -2. Now on both of these problems, if you were to take any one of these values and plug it back in for x up here, you will find that y is going to equal 0. If you take either of these x values and plug them into x up here, you will find that y is equal to 0. Flip your paper over, and we'll have a couple more problems. This question asks it in a different way. You'll recognize that we already have y, or our output value, set equal to 0. So all we're asking is, what can I plug in for p that makes the statement true? What value for p makes this side equal 0? I'm going to factor it by group. I'm just going to factor it. -20 is our target number. What multiplies to -20 but adds, remember there's a positive 1 in front of that p. What multiplies to -20 but adds to 1? The answer is 5 and -4. So I have 0 equals p plus 5, p minus 4. You could check your factors. You could check that p times p is p squared. 5 times p is 5p. P times -4 is -4p, but those add to 1p. And then positive 5 times -4 is -20. We factored it correctly. Take p plus 5, our first factor, set it equal to 0. Take p minus 4, set it equal to 0. Set your factors equal to 0 separately. Subtract over 5, add over 4, and you get our two answers. P equals -5 and positive 4. So this is the location on the p-axis where it crosses the p-axis, or this is the value that makes it the right-hand side equal 0. Also along with 4. All right, on this one, we'll recognize that our coefficient of our quadratic term is no longer 1. It's now a 2. So I have to factor this by grouping. I'm going to take the 2. I'm going to multiply it to the 18. So I take 2 times 18, which is 36. 36 is our target number. What multiplies to 36, but when I add it together, adds to equal to -15? The answer is -12 and positive 3. No, not a positive 3, a -3. -12 and -3. They have to multiply to be a positive. A negative times a negative is a positive 36, but a negative plus a negative is a -15. So I split my middle term into -12a and -3a. I bring down the 18, I bring down the 0, and I bring down the 2a squared. So this statement is equal to this statement. These two terms can combine together to equal -15a. I factor by grouping. We look at the first two terms only. What is in common between 2a squared and -12a? The answer is 2a. Take that 2a out and leaves behind an a minus 6. I take this a minus 6 and I rewrite it exactly as it is, but I give myself a little space here. And then I ask myself the question, what do I multiply to a to get -3a? And the answer's -3. And then I check, is -3 times -16 positive 18? The answer is yes. Now a minus 6 is in common, so I can take out a minus 6, factor that out, and it leaves behind a 2a minus 3. So I have factored it, but now, since we're not just factoring this problem, we are solving it by factoring. I need to take my two individual factors and set them equal to 0 separately. I add 6. I have one solution, a equals 6. I add 3. But this is not just an a over here. It is a 2a. So I have one more additional step, divide by 2. So I get my two solutions, that a equals 6, but a also equals 3/2. If I was to take 6, plug it in for a. If I was to take 3/2, plug it in for a, you'll get 0 equals 0. So in this problem, you'll recognize that it's not set equal to 0 right now. Our linear term, or actually no, this is the constant term, is on the right-hand side of the equation. So I need to subtract the 18 over first. You have to set it equal to 0 before you do anything. So I subtract over 18. So I have 4x squared minus 21x minus 18 equals 0. Now I can factor by grouping. Take the 4 times the negative 18. 4 times negative 18 is negative 72. Our target number is negative 72. What two numbers multiply to be negative 72 but add to be negative 21? The answer is negative 24 and positive 3. So again, I can split my middle term into negative 24x and a positive 3x. Bring down the 18, negative 18, set it equal to 0, and bring down your 4x squared. This is equal to this. These two combine to be this one. Look at the first two terms only. What's in common between these first two only? The answer would be 4x. I could take the 4x out. What do I multiply 4x by to get 4x squared? X. What do I multiply 4x by to get negative 24x? It's negative 6. Take this x minus 6 and rewrite it. What do I multiply x by to get 3x? That would be positive 3. And then check. Is positive 3 times negative 6 negative 18? It certainly is. Don't forget your equal 0. Now you can factor out x minus 6. And when you factor out x minus 6, what does that leave behind? A 4x plus 3. Now, all we have done is factored it. Now we have to solve it by factoring, by setting both terms equal to 0 separately. So I have one x minus 6 equals 0. I have the other. 4x plus 3 equals 0. Add 6. One answer is 6. Subtract 3. Divide by 4. So I have two solutions. 6 and negative 3/4. Again, my constant term is over here. Let's bring it to the left-hand side by adding it. X squared plus 14x plus 49 equals 0. What multiplies to 49 but adds to 14? 7 and 7. Well, this is a special case, if you recall. This is a perfect square. That's a perfect square. It factors to a perfect square. But we can still solve this by setting both factors equal to 0 separately. But you'll recognize that when I set both of these factors equal to 0, I get two answers, but the two answers that I get are the exact same value. They are both -7. This is our situation where I have one answer, but you have what's called a multiplicity of 2. There are technically 2 solutions here, but they both happen to occur at the same value of -7. So there's one solution, but kind of 2. All right, everyone's favorite, the word problem. Let's look at the word problem. You are constructing a frame. For the rectangular photo shown, you want the frame to be the same width all the way around and the total area of the frame and the photo to be 315 squared inches. What should the outer dimension of the frame be? We should understand with a rectangle, we are given the total area. You should be thinking in your head, how do I find the area of a rectangle? Well, the area of a rectangle is the length times the width. That's the area. So now I should be thinking, how do I find a length? How do I find a width? So let's look at our image. We know that this distance on our picture is 17. We know that this distance is x, and we know that this distance is x. If I was to call this entire distance the length, how would I get from here all the way over to here? Well, I would take this x and I would add it to 17, and I would add that to another x. So I'd have the statement x plus 17 plus x. I can add those two things together, getting 2x plus 17. I can do the exact same thing over here. This is x, this distance is 11, and this distance is x. So the entire distance is 2x plus 11. So my length is 2x plus 17, and my width is 2x plus 11. Remember that when you're adding x's, x plus x is 2x, not x squared. It is 2x. So my length of 2x plus 17 gets multiplied to my width of 2x plus 11, getting my area of 315. Now, some of you might think this is factored. Well, it's not quite factored yet. We have to have it set equal to 0, not 315. So I need to double distribute this side, subtract the 315 over, and then factor it. Because you have to have this factored, but this must equal 0. So 2x times 2x is 4x squared. 2x times 11 is 22x. 17 times 2x is 34x. And 17 times positive 11 is positive 187. Now I subtract 315 over. And I can also combine those two together, getting 4x squared. 22 plus 34 is 56. X. 187 minus 315 is negative 128. All right. Some of you might look here and be a little nervous. We have a 4 as our coefficient on our quadratic, and we have 128 over here. If you were to factor this by grouping, you'd have to take this 4 times negative 128, get an absurdly large number, and then add it to this. I'm going to check. is there a greatest common factor already? Does 4 divide into these 3? And actually, it does. I can divide all my terms by 4. And technically, you have to divide this by 4, although you just get 0. 4 divided by 4 is 1, so I get just x squared. 56 divided by 4 is 14. And negative 128 divided by 4 is negative 32. And 0 divided by 4 is 0. Now, this is a much easier question. What multiplies to negative 32 but adds to positive 14? So we have our target number of negative 32, but it needs to add to positive 14. So that's going to be 16 and negative 2. So I can factor this to x plus 16, x minus 2. What do I do with these two things individually? I set them equal to 0 separately. Subtract 16 over, add 2 over. Now, look at these two different values. Both of these will make this equation equal 0. Both of these will make this original equation equal 315. But look at the problem itself. We are asking for the length and the width of a frame. Can this distance, the width of the frame, which is our x, can this dimension right here be negative 16 inches? No, it can't. So that answer does not make sense in the context of our problem. So therefore, our length is going to be 2 times x, which is 2, plus 17. 2 times 2 is 4. 4 plus 17 is 21. So our length